Hello, CIS30A. In this week, we're going to cover exception handling in Python in week 4. We are to talk about class objects again and also to explain the methods and attributes, how to use object to access class methods and attributes in a Python script, along with looking at inheritance and how to use multi-class in a program. So for this week, we are to view our notes and videos, and this is part 1 of the lecture video. Then you're going to complete lab 4, which we are going to work on exercises with exceptions, classes, inheritance. Then you are to work on week 4 assignment, which is a review for quiz 2. I will release quiz 2 in week 5. So this is a preparation for our next week quiz. Then I want you to continue to work on your course project. If you have questions about the project, please contact me or make an appointment to see me if you cannot stop by the office hours. I also am releasing the final review, which allows you to prepare for the final exam. That's going to be in the last week of our course. So you can start working on the final review, take a look at the questions. The final exam will be multiple choice, and I will release the final exam during week 6. So in week 4, we are to look at first our notes. You can find the notes here. You need to download it and be able to view the notes. So in the notes, to start, we're going to talk about exception handling. Now, this is one of the requirements in your course project. So we really need to take a look at how we would handle errors or possible errors inside your script. So if you're expecting to have some form of errors, you need to incorporate exception handling processes. Or in the case where if you have user input and in some form of input that would generate some error, you want to use exception handling methods to be able to address the errors or get the program to move on so it doesn't halt. And that's the whole point in exception handling, is to prevent your program from stop running. And a lot of the times we're looking at logical errors or possibly something that would cause your program to stop, and we wanted to make sure that we have the proper processes to get our program going, to keep it going. So when we're looking at exceptions, we need to think about the type of exceptions that we would have. Common exceptions for beginners would be your syntax errors. Now that can really be manually corrected, but in the case where logical errors or something like when you're operating division by 0, we would be able to handle it using some of the built-in methods to keep our program going. So a good example of your exception handling is when you are racing up or something, when the user tried to operate division by 0, as I mentioned. The interpreter would then recognize that, and we don't want our program to stop, so we want it to continue. So we want to incorporate the processes, the functionality of the program to get through the rest of the program. So now if we're looking at the built-in exceptions, Python has these built-in exceptions. Finally would be used when you want to clean up some form of actions, whether the exceptions occur or not. So finally is often used when you're thinking that possibly an error would happen and you want to incorporate finally. Another built-in exception handling is your assert. And this is a way that we can incorporate a condition that would be triggered in the case that the errors occur. So assert, think of it like if we were to incorporate if-else condition within our script, so that way it would branch in the case that the error happens. So if the error happens, it would get through the body of the actual script for the if and be able to execute there. Else it's going to move to the next part of your script and be able to handle the rest. So we can use assert in our program to allow a trigger in the case the exception is inside of the script. Then we can use the raise command to trigger a certain exception manually. So in this case, if you wanted to force it to trigger an exception, we would want to use the raise command. And lastly, we can use try and except. Similar to C++ or Java, would be try and catch. For Python, we would use try and except. So if you want to try out a block of code, then you would put that under try, and then to recover from it, the recovery process would be under accept. So I'm going to illustrate some example for you so that way you can see a little bit more on how. And so first we're going to look at an example using try. Now, notice that in this example at the top, we are importing sys. And sys allows you to see the output of different types of exception, or the type of exception that's occurring. And in this example, we have a list called random list. And inside this list, it has multiple types. So we have string, we have 0 under integer, and 2 is under integer. So we have a mixed type list. Then to access the element in the list, we would then use a for loop. And nested into the for loop, we would have try. And this is the built-in exception handling. So we would then print, and we wanted to look at the ratio when we're divided by integer. So in the case where it's going to access the first element, which is A, and that's a string, it's going to operate that, and we wanted to show what kind of exception that is occurring. And then it's going to get to the next one. It's going to print. First, it's going to print the exception that occurred, right? The type of error that you see. And then it's going to move on to the next element, and it's going to continue. So in the case where if we're also dividing by 0, if the exception occurs, it's going to say division by 0 and the type of error. So the output that you see from this program is going to be, for the first element, that's going to be A. And it's going to tell you that this is a value error because A is a string type. And when we're taking 1 divided by a string, we're going to see that it is a value error. Now, this would only show if you have the sys module incorporated. If you don't include this, you don't import the sys module, you will not be able to show the error type. Now, do we really want the user to see the error type is the question for you as a programmer to really see. So in the testing aspect, we would want to incorporate that module so we can see if there's possible errors that we would handle, or possible exceptions that it's handling as a program. on the second element, which is 0, it would then show that 0 division error is occurring because mathematically we cannot divide 0. So it would show that this is a division, the 0 division error, and then it's going to move on to the next part. So for 2, when it divides it by 2, it's able to take 1 divided by 2, which gives you 0.5. So nothing really occurs there. So as you notice that we first use the import sys here to incorporate the sys module so we can see the type, but inside the for loop, nested in the for loop, we're using try and except. So in the case where when it's going through try, it's going to try different values in the list starting with A. When it sees the error, or when the exception occurs, it's going to get to the except. So the except is if the exception happens. Now, if it doesn't have the exception, when we come across the 2, when it tries with the 2, so first it's going to implement the try here, 1 divided by 2, then it's simply skip the except, and then it's going to get to the output where it shows that would be 0.5. Now, in the case where A, when it tries A, there's an exception that occurs, so it's going to go into the except, and it shows that that is a value error, which is here. In the case of 0, second element, it tries the 0, then it shows that it is a 0 division error, and it would then print, oops, that's a 0 division error, and then next entry. So in such case, if you implement try and except, you want to try a certain value, or you want to attempt a certain process. Now in the except portion, that would catch the exceptions and show if we wanted to print that out. Okay, so that illustrates on how we can implement try and except, and you can see that example on page 1 and page 2. I also explained that here on the top of page 2. Now another way that we can use the try and except to catch the exception is when we use break and pass. So notice that inside the try, we need to break from that, and in the try we can also use pass. So in the second example, it shows here that the try clause can have as many number of except clauses to handle different exceptions. So if you're expecting a lot of different exceptions, you can also have different except section in your script. However, only one will be executed in the case where you would have one exception occur. So we can look at the type of error, and we can also have it handle the different type of exception. Then we can use the pass to be able to have it move forward. Now in the case of when we're using try, except, and we incorporate the raise command. So in this one, you can see that I wanted to try print 1 divided by 0. And we know that it's impossible to have the zero division there. So in the except, because the exception occurs, it's going to get here. And what we wanted to do is we wanted to incorporate erase runtime error, because if this is and you can look at the actual type of error based on our last example. With the runtime error, then it's gonna show this in your traceback. So in the output, what will happen is that it's gonna, once the runtime error is erased, it's gonna display something happen, because here we confirm that this is a runtime error. As it sees the exception, it's gonna get here and it's gonna show something happen inside the shell or in your console output. And with this example, what you can see is we do try and accept. We try to print 1 divided by 0. It causes an exception. It's going to move to the except area here. We nested the raise command here, and we specify the type of error. So when it raises, when we wanted to raise the manual, we just simply show this. But throughout the program, as you notice, that it still sees the zero division error. That's also a type of error. We manually raise a different type of error, which is a runtime error, to cause this to show. So in this program, we're using try, accept, and also raise command, where we can manually raise an error. And you would often see this for testing purposes from a programming side. We want the user to have the program running. So in the case where if you need to manually raise an error, then you simply use raise, and then you specify the type of error and what you want to do with that error. In the next part, I'm going to talk about using assert. So assert is used to really debug your error or your code. It lets you test the condition of your code, and it's the output of this is just going to be true or false. So now we can have it raise or add different handling processes within. So in this example, what we're doing is we have a try. We're going to attempt, have the user input a value, and take that value, and we're going to operate modulus 2. Now, if it doesn't have a remainder, we're going to print that is an even number. Otherwise, we are going to show the reciprocal of that number. So in this one, what I wanted to show you is that you can incorporate the input from the user, and we can apply a condition. So think of assert is a way that we can assert a condition into the actual after it has attempted, which is after the try. And if in the case where if it has some form of exception, then we would print otherwise. So it takes place of like a conditional branching inside your program when you're trying to handle a certain exception. So here's our example program. So first, we're going to try. So when I run this program, it's going to ask me to enter a number. So let's try a 2. And once we insert the 2, it's then going to use the value that was input, operate the mod 2, and check to see if it is equal to 0. Since 2 divided by 2 is going to give you 0 remainder, then it's going to go into printing this part, which is it's going to show the reciprocal after it takes 1 divided by R2. So once we enter the 2, we press enter, and it's going to show 0.5. So if this condition is checked true, it then would go to this area with the else. So if you're using try except with assert, then you can incorporate the else in this to check for certain conditions. Now, if we run this program again and we try to input a 5, then what happens is when we input the 5, it's going to apply the assert here. 5 is plugged in here. 5 mod 2 is going to give you 1. So it doesn't check. It's false for this condition. Then it's going to print the exception. So we can even use exception handling in the case where we wanted to validate certain things or check for certain things or test our program using try and except and assert. So in this program, as you can see, if it's an odd number, it's going to try that. It's going to use assert to check for a condition. Then it's going to, if the condition is not true, it's going to get to accept. If the condition is true, it's going to skip the accept and it's going to go to else. So you can follow the notes on page 3 and page 4. It talks about the assert using try and accept. Next, I'm going to talk about try and finally. And this is going to tie back to the last unit where we worked on file operations. So in this program, we first have declare F here. And for F, we wanted to open. Our file name is test.txt. We're going to have it read. And then we're going to try print check errors. And then we're going to have a finally section where it's going to read the lines and then it's going to close. So when you're using finally, it's going to run whether there's error in the try or not. In this case, where I have a file called test.txt, and so when I run this program, it's first going to try, and we open the file, and it's going to try print checking errors. And then when it's finished, it's then going to go to the finally here. It's going to read the lines, and then it's going to close the file, and it's going to print finish. Now, if we wanted to print out the lines that it reads in from the file, we could do that. But finally is going to execute whether try has an exception or not. Now, in the case where if we wanted to use finally and with the exception, so to handle the error here, what we did was I added the raise. I forced it to raise an error, so that way you can see that finally is going to execute no matter what happens. So we have a file and we wanted to read that file. Then we're going to try, and in the try, we force it to raise an exception, and in traceback, it's going to print hi there. And then the next part, we have finally, and we're going to show that it is going to print exceptions. So when we run this program, what will happen is, see how finally it's going to pop up exception first? It's going to show that no matter what, whether the error occurs or not. Then since Thani has shown me some different level of responses here regarding the exceptions, then we can click close. And since we're using the raise, it's going to show the type of error that we raise manually, and we wanted to show hi there inside the parameter of the error, so it shows that here. That would be the name error. So if you wanted to manually raise the error, you can use raise command, but for finally, whether you are successful with the try or not, whether the exception occurs or not, whatever that you put under finally is going to occur. So you can also check out the notes. Another good source that you can use is the Python documentation, so you can see other examples that's being used for the purpose of exception handling. But for our notes, you can refer to page 1 through 4 for exception handling. And also watch my lab videos where I would illustrate on how this would be used in your lab exercises. And this concludes part 1 of our lecture, which talks about exception handling.